Welcome back. Then what I had left out on lines is how to get a point, a distance of a point from a what? From a line. Now what we need to know here, how do we know that the two lines, like if this line A and line B, they are at the angle of 90. The line A and B at an angle of 90, when their dot product give you 0, like when you have A dot B should be giving here 0. This one can be proved in the way that if we go for the dot product, we shall say that A dot B will be equal to the absolute of A times the absolute of B, then the cos of the theta, but the angle in between them is 90. Now it means theta will be 90. We shall have A dot B absolute of A dot absolute of B cos of 90. Cos of 90 is 0. If the cos of 90 is equal to 0, it means 0 times the whole of this one will be 0. Then at the end we shall have A dot B is 0. Now if this one happens, we say those two these two lines are what? We shall clearly say that those two lines are perpendicular. Now we use this concept when we want to deal with how do we get a perpendicular distance of a point from a line. Now for perpendicular distance of a point from a line, we shall choose a point A with the coordinates ABC from this line, which has a direction vector B1. This one can be the line R is OA, then plus lambda B1, and this one can be we can expand it further, that any point X, Y, and Z will have coordinates which I can call A1, A2, A3, then plus lambda B1, B2, B3, just like that. Then I can compress both together, that at any point X, Y, and Z, the line will be A1 plus the lambda B1, and the A2 plus the lambda B2, and the A3 plus lambda B3. This one will be the point at any line. If this is our point A, which is A1, A2, and A3, then any point that I'll be choosing along this line, like if I choose it here, it will have this equation. If I choose it here, it will have the same equation. Then I want to choose it at a point which will be directly below this one, so that I can choose and take, and say, let me call this one point M. Now its position will be these ones: A1 plus the lambda B1, then A2 plus the lambda B2, then A3 plus the lambda B3, just like that. Now what I need to do is to get the direction vector of this line MA. Now if I get the direction vector of MA, then when I dot it with this B, I'll be getting 0. It means MA, then when I dot it with B, I'll be having 0, because these two will be at an angle of 90. What is so special here is getting this one. If you get this one, you have a very good way to do what? To go about solving it. Now let's do it practically, but you can pause a bit on this video and you see what we are doing and how we can go about them. Now if we choose any point, I'm going to choose a point which is in Cartesian form, then we convert to vector form, then we use the point. Now if I take a point to be x minus 1 over negative 1 is equaling to y minus 3 over a 3, then this one will be equaling to a negative all 4 minus z over negative 1. Then I need of something like, I want something that will trigger our mind and we start to think beyond. Now also let me add a negative 1 to this one. Now when you want to convert this line, you see it, the x, the y is negative, the z is the other side, it is also negative. And we said when we have them like this, we have to make them positive. That is the first work to be done. Now if you want to make them positive, you have to divide the value which is here on y and the value which is here on z. Here it is negative 1, negative 1. Now we do that. X minus 1 over negative 1 to be a negative y over negative 1 minus 3 divided by negative. You divide it throughout. 3 divided by negative 1, then this will be equaling to a 4 divided by negative 1 because z is negative 1. Then minus z over negative 1 divided by a negative 1. Now you will see that you'll have x minus 1 over negative 1 to be equaling to negative 1. You'll have y. Now this and the negative and negative plus 3 over negative 1 and 3 will be negative 3. Then this one will be equaling to negative and 4 will be minus 4. Now z will become plus z, and this one will become negative and negative a 1. Then from there you can arrange to begin with z. X minus 1 over negative 1 will be equaling to y plus 3 over negative 3, and this one will be equaling to a z minus 4 over a 1, something like that. Then when if I have that, then I go and write my, if I have x, y and z first values and they are all positive, then I will go further and write my vector equation that my r will be equaling to a point. I put this one to be negative. If I put a negative, this one will be plus negative 3 and 4, then plus any value lambda into negative 1 minus 3 and 1. Now this is the vector equation of the line. Now if I get the vector equation, now things have tried to simplify a bit, but observe this step and how we reach down until this space, this step. You can go on pausing and observing what is really taking place into those videos. Now I want to combine all this vector into one value, so that I have r is equaling to a 1 minus lambda minus 3 minus 3 lambda, then 4 plus lambda. This is my complex vector. Then I want to get the distance of this line from any point. Now we want to get a distance of that line from any point. A point I can take, point which is 1 0 0. That is the coordinate I've chose. You can choose yours depending, and the question will dictate for you the point to choose. Now for me, I will draw my line like this. Now if I draw my line, I will need of a direction vector b, and that direction vector b will have coordinates. You still recall that our line here, this is the b, will be negative 1, negative 3 and 1. Now meaning my one will be a negative 1, negative 3 and 1. Now I will choose off this point which is required me to get. I can go to point A, which is 1 0 0. Then I want to choose a point which is directly below that. When I dot it with B, I'll be getting 0. Now this point will have coordinates which we have known now from here, which will be a 1 minus lambda, a negative 3 minus 3 lambda, then a 4 plus lambda. Then I need to get this. I can go to point M here. Then I need to get the equation of this line, so that I have a vector pointing this side and another vector pointing this side, which will be perpendicularly. This one will be vector B, this one will be vector, I can call it vector D. You see that this is vector D, but D enkana MA. You see that D is from M to A. Now I can dot these ones, and I say that if I get D dot B, this one has to be giving me 0, because they are 90 degrees. From the beginning of this video we talked about that. Now I'm going now to get vector D, which will be equaling to MA, which will be OM minus OA, and vector D will be equaling to OM is OA minus OM. Now OA is this vector A, which is given. OA is that which is 1 0 0. Then minus OM is our vector 1 minus lambda minus 3 lambda, a 4 plus lambda. Then you subtract it, 1 minus 1. You see this one to give you 0 already. Then minus lambda. Then you have D as lambda. Then this negative and negative, you have 3 plus 3 lambda, and it will have again lastly, it will have a negative 4, then minus lambda. That is your D. Then you dot D dot B will be getting you 0, and D is lambda, 3 plus 3 lambda, then minus 4 minus lambda. Then if I dot it with b, which is -1, -3 and 1, if you should recall, d was -1, 3 and 1. You pause the video and first go back and prove that what we are doing is okay, and we said this is equal to 0. Then we multiply this time with this will be minus lambda, this time with that will give you negative lambda. Then when you go for lambda times the -1, it will be a minus lambda plus, then 3 times -3 will be -9. This and this will be also -9 lambda. Then 1 times 4 minus 4, 1 times negative lambda, and you say this is equal to 0. You see how life is now improving. Our life is going now smoothly. Negative lambda here to go to -10, -11. You see that you shall have -11. Now we go for 9 minus 9 minus 4, that is -13 minus 11 lambda. Just like that, and you say this is equal to 0. Take this one the other side. -11 lambda will be equaling to 13. Then lambda will be divided by -11, -13 over 11. Now we have obtained lambda. Then we substitute lambda into d. D will be equaling to lambda, which is -13 over 11. Then a 3 plus a 3 into -13 over 11. Then a 4 negative minus lambda, and minus lambda, which is -13 over 11. If you still recall our d from this point, don't forget steps are so important in this work. Then from there you shall obtain a single value of d, which will be a 13 over 11. You will compute -33, that is 36, 39 negative, then 36, something like -3 over 11, something like that. I'm not so certain. Positive 44, then 13, something like minus 21 over 11. It will be like that. This is d. Now if we obtain d, and if you still recall our diagram, you see d is distance from a to distance m. You see d is from a to m, and that is the perpendicular distance of point a from the line. You see that d is from a to m, and our perpendicular distance which they want us to obtain is the distance from a to what? To m. Now it means we have got the distance. Now the required distance, we have it. Just here it is in vector form. Now what you need to do is now the required distance, you get its absolute, you get its magnitude, you get a single value. Our distance will be a 13 over 11 squared plus a minus 3 over 11 squared plus a negative 21 over 11 squared. Then you put in a square root, then the distance will be a single value obtained in units. You add the word units, the value you have obtained, you add the word units, it will be in centimeters, meters, millimeters, any value, but the word units is important. That is it for today. The video has been long, and you try to go slow, bits per bits, then so that you'll be familiar with the lines. I think I've talked everything about lines. The next video I'll be shooting, I'll now shoot to the planes. See you. Don't forget to subscribe so that you'll be informed earlier of what I've posted.